Integration by parts. So this integration technique is very different than U substitution. And that's what we're going to be doing is about 6 different integration techniques. So just need to think about what we have and where we need to go. So what we're going to have is two things multiplied together, and we're going to call one of them u and the other one dv. And so it's going to be our choice to identify the u and dv from the original integral, and then what that will do is break it up into 2 parts. Okay, so I'm going to just show you and talk you through many examples and then kind of show you different types. So this isn't usually in any textbook. Every textbook has u and dv. Every textbook uses the integration by parts with the letters u and v, even though they're very close to each other, so you're going to have to be careful. But I'm going to break them up into types to help you identify which to let equal u and which to be dv. All right, so here we have our first one. I'll show you. So here I have here I have x times cosine of x dx. So you know when there's 2 functions multiplied times each other, you cannot just go take the antiderivative of each of them separately. So what I mean is, let me just write it down here. It would be really bad to say, oh, I'm going to take the antiderivative of x and get x squared over 2 and take the integral of cosine and get sine and then put a plus c down there. That's really bad. You cannot take the antiderivative of each term separately when they're multiplied like that. Okay. Let me erase that so we don't have that anymore. Okay, so when you see 2 functions multiplied, x times a cosine, I'm going to show you a pattern. So let's let u equal the x. And I'm going to let dv equal the cosine of x dx. So this is very different, where you're going to let u and dv equal 2 different things, and the dv has to include the dx. So now from the u, I'm going to take the derivative. So the derivative of u is du over dx, and the derivative of, let me just write that over here. So the derivative of u, so if I take the derivative with respect to x on both sides, this side here would give me du over dx. The derivative of x with respect to x, gives you the number 1. So that means du equal dx. So that's how I get this. I'm going to take here, I'm going to take the integral of both sides. So let me just write it here, because I'm going to want you to get to this short stage. So if I have dv equal cosine of x dx, I'm going to take the antiderivative of both sides. So the antiderivative of v, of the number 1 here, is v. I'm sorry, yeah, so I said that wrong. The antiderivative of 1 dv is v. The antiderivative of cosine of x is just sine of x. And I really do have a plus c, but what I'm going to do is I'm going to just save the plus c for the very, very end. All right, so the antiderivative of dv is v, antiderivative of cosine is sine. So then I put it together. So here is the integration by parts. uv minus the integral of v du. Of minus integral of dov, duv, of minus dov, as I like to say it. So u and v, so u, which is x, and v, which is sine of x, right? So there's my u and v, minus the integral of v du, sine of x dx. So then I asked myself, can I take this antiderivative? I can, and it's negative cosine, so there's my answer. And I put one big plus c at the end. So this is called integration by parts, because it takes one integral and breaks it up into 2 parts. So what this means is that if I took the derivative of this, I would get x cosine of x. I'm not going to go do it. It's just going to be a lot of extra work. But that's what an antiderivative is, right? If I take the derivative of this, I would get this. Okay. So we're always going to be breaking up this one integral into 2 parts. The second integral is one that I hope I can do. Sometimes it's going to take a little bit of work. This one did not. All right, so let's check and see if I had made the other choice. If I had let u equal cosine, and if I let dv equal x dx. Again, the dv has to include the dx. So now if I take if I take the derivative of cosine, I get negative sine of x dx. Don't forget the dx. The dx has to be included here, and it has to be included here. If I take the antiderivative on this, antiderivative of dv is v, antiderivative of x is x squared over 2. So now I put it together. So uv minus the integral of v du. So stop and think. This is where you have to stop and think. A little thinking bubble here. Is this worse than the first integral? Better? Can I do this integral? So this integral has two functions multiplied times each other, and this time it's not just x times a trig function, it's x squared times a trig function. So this is worse. So this is a bad choice. So you would not continue to work this and make it better. You would say abort, stop, switch what you're going to let u and dv equal to.